Yeah.
Okay, so these, okay, so let's look at 2, 5 then. So here we're going to solve for x. So it's pretty obvious 9x equals negative 18. X equals negative 2. Here, negative 4x plus 32 equals s. Negative 4x equals negative 48. X equals 12. And this is pretty obvious. You can move the 2 onto the other side. Divide by 2. And you get that. So if you think about what we're doing here algebraically, like for number 1, we're adding 3x to both sides and dividing by 9. We're actually using the addition property because we're adding 16 to both sides, and then the division property because we're dividing by 9. Or for 2, we're using the distributive property, distributing the negative 4, subtracting the 13, divided by negative 4. So essentially, we're using all these steps to prove why x equals a certain number or a certain expression. Or for number 3, I use something called the subtraction property because I move the 2m over and then divide by 2, again, division property, right? And that's what's being mentioned here. These are algebraic properties of equality because you're doing it to both sides of an equation, so it's fair treatment. Like if a equals b, then of course, if I add c to both sides, that's fair, right? Or if a equals b, I subtract c to both sides, that's fair. Or if I multiply both sides by c or divide both sides by c, again, those are both fair. Or if I substitute, if a equals b, I can replace b with a or vice versa, and that's fair. So the way this will work, for example, for 2.51, obviously I'm going to add it 3x to both sides. That's called the addition property of equality. So I have this now. Actually, I'll write like this. Then when I have, which becomes 5x, then I'm going to divide both sides by 5. And that's called the division property of equality. So that's all that's happening there.
Okay.
So
Pretty
we do
basic.
something similar here.
The distributive property of equality.
Correct.
And then you add the 8 the other side. So addition property of equality.
Yeah, so you have this. That's
Yeah.
addition property of equality.
And then you do division property of equality, and then it's
Correct. And then you
x
have
equals negative 2. X equals negative 2.
correct.
Okay. So you're just explaining what steps are.
Exactly. Yeah, I mean, we know this makes sense because we do so much algebra these days, but yeah, that's really what we're doing. So
Okay.
um
Why do you always record it? Like, do you like play it back or?
yeah, so I'm gonna share these with you, that's why.
Um.
So you have these always for reference throughout the year.
Okay.
Okay, so here, farmer is planting growing grapes in his triangular shaped lot. Luckily, the farmer already knows the total area of his lot and has spent some time measuring the height of this lot. Save some time, he just needs to do some math. So you want to get B by itself. So the way you would say is you say A equals, that's given. So usually I'll kind of like number these like this. Then I'll multiply both sides by 2. And then divide both sides by h. So, so that's what this is called a proof. This is kind of the beginnings of a proof. There are other properties we'll talk about, like reflexive is when the same thing equals itself. Um, so you'll see why sometimes we'll need to do that. You don't really use symmetric prop of equality, but if A equals B, B equals A, I mean, that's pretty obvious. But we definitely do use reflexive quite a bit. Transitive means if A equals B and B equals C, then A equals C. That's also like substitution in a way. Um, so for here, if measure of angle 6 equals measure of angle 7 and 7 equals 6, we call it symmetric property of equality because you're just reversing it. If J equals KL and K equals 12, then JK equals 12, we call it transitive. It's kind of like saying if the 49ers beat the Seahawks and the Seahawks beat the Rams and the 49ers beat the Rams. We know that doesn't always work in sports because anything can happen, but that's called a transitive property. We call this
Okay.
reflexive because it's just a reflection of each other. That's yeah, back to transitive again. That's symmetric.
Wait, what's the metric?
You just reverse.
And then reflexive is the same exact thing, and then
Just reverse, yeah. Give me a sec here. Okay. Um, right. Okay, so that covers that one. Let's move on to the next one. So yeah, so obviously measure of angle 3 equals measure of angle 1. AB equals CB, CD equals TU, so AB equals TU. So if you add AB to both sides, you could add it to, if you add it to the left side, you should add it to the right side.
oh man.
Hmm. Yeah, now we're beginning the process of writing a proof. So what we're going to do is state what we're given, AB equals CD. Okay. Then I know that BC equals BC. I mean, duh, right? We know this. I mean, it's pretty obvious.
Yeah. Yeah.
But we have to say it, so we can call it reflexive.
Okay.
Now, why do I do that? Because then I'm going to add that to both sides of the first statement. And that's what I call the addition property of equality. Then, um, well, AB plus BC equals AC. And at the same time, I could say BC plus CD. And we call that segment addition postulate. I think we talked about that earlier. I don't remember if we did. Because you're adding two segments to get a big segment. And then lastly, because AB plus BC equals BC plus CD, then AC equals BD. And we call that substitution. So that right there is your first proof.
Okay.
So, and these can be a little tricky at times. They can be a little confusing, but yeah, that's how we approach these kind of situations. We state what we're given and then kind of logically kind of go through this proof like, oh, okay, well, I know that BC equals itself. It's going to add that to both sides. Then, of course, we realize AB plus BC equals AC because that's what we have to prove eventually. AC equals CD, sorry, AC equals BD. So we do that, and then we can set them equal to each other. Okay, so we'll keep moving. So Rose's favorite Julia starts with the same letter as her first name. So this is all about logic. I mean, it's pretty obvious it's going to be this one.
Yeah, Helen does not like gold or opal.
Keanu does not like gold or opal. Okay, so I'm going to have you go through the rest.
Tina Bella gift diamonds. Okay. Okay, so then wouldn't Tina have diamonds? Okay, and she has this. Um, Danny's favorite jewelry is the gold and silver. Can't be silver, so it's because okay. Jenny, Jenny's gold. Rose is ruby. Kaylin is silver. Tina is diamond, and then Vicky is opal.
Yeah, so Tina clearly has diamonds. So Keanu's got to be the silver, right? And then, yeah, by process elimination, um, yeah, because then Keanu's silver, then Jenny's got to be gold, right? Yeah, and then Vicky is opal. So yeah, so it's just good to like, it's just logic really that you're doing.
Hmm.
Kind of neat, the kind of like logic puzzles in a way.
Should I do this one?
Yeah, let me just maybe adjust a tad.
Yeah, so I'm gonna just
There we go.
find out each one spent and who forgot to buy bread. Oh, that's hard. Okay, so Angelica forgot to buy detergent. Detergent. Right. Oh, Mm. Wow. The woman who spent $50 is a Rachel, or the one who forgot to buy milk. Mackenzie spent 30. Okay, and Rachel spent 10 less than the woman who forgot to buy coffee. Wait, so do I check this off too? Yeah, what? How do I read this? Like, oh, okay,
Yeah,
okay.
so
I
so
see.
she forgot detergent.
Oh, so that means Angelica spent $30, right? Right? Okay. Woman spent $50 either Rachel or the woman who forgot the milk. Either Rachel for yeah. So Rachel didn't forget milk.
Oh wait, I don't know why I put check mark. That makes no sense. Sorry.
What?
Oh, but the
Oh,
$30 does go with detergent. Never mind. That does make sense.
does that mean Rachel spent $20?
Oh, Mackenzie spent $30. Hold on. I'm confused now. Angelica did not spend $30.
Oh, okay.
We know there should be an X here.
Mm,
Okay.
mm, 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 mm. Okay. Then Rachel spent 10 less than the one who got my coffee. So, oh, where is it? Well, I can't, okay. Mm, So, Angelica forgot to buy the paper. So, here, so she didn't forget anything. She didn't forget this. This, this. The woman who spent $50, either Rachel or the one who forgot to buy milk. 50 for Rachel or the one who and she didn't spend 80. Wait. Can you erase this X?
Oh, sure.
I can erase it. Because Mackenzie spent 30. So Mackenzie and she spent okay. So $50 either Rachel or the one who got the milk. So it can't be Angelica because she forgot detergent. So either Rachel or Cynthia. And 50 is the most. So that means Cynthia spent $50 and Rachel spent $40. Okay. Mm, mm, mm. And she said, oh, oops. And she spent $20. Great. Okay. So now it's just easy. Detergent. Okay. So we just spent 10 less than the ones that got my coffee. So she spent 40, 50 is Cynthia. So Cynthia forgot that coffee. Oh my god. This Cynthia forgot my coffee. Okay. And then we're gonna spend 50. We go Rachel. Hey, what? That means $50 to do the seafood. I'm so confused. That's funny.
So Rachel did not buy coffee,
Yeah,
and she clearly did not buy detergent.
but she bought milk. Rachel bought milk because she spent 50. No, wait, because she bought milk.
And
Cynthia
$50
bought milk.
goes with milk
So she bought bread.
or Rachel.
Then she bought bread. She bought coffee. So you're gonna be from Cynthia. Okay, that's it. That's it. Let's not fill it in then. So you said 30, Mackenzie, without coffee. Facility, Rachel's without bread. Okay.
Okay. So you got Angelica is $20 in detergent. You got Cynthia's $50 in milk. Yeah, Mackenzie is
And,
$30
and bread.
in coffee.
And then
Rachel's
Rachel's
$40
and bread.
in bread. So Rachel definitely spent what, $10. Well, no, that doesn't make sense because Mackenzie,
Yeah, because then
hold on.
exactly. Because if Rachel spent 10 less and only forgot to buy coffee,
I think
then
actually,
did Rachel spend $30?
no, I think it should be this. I think Angelica should be $40, right? Because if Rachel spent 20, that's definitely 10 less than Mackenzie. You have Mackenzie buying the coffee, right?
Okay.
Yeah. Yeah, $50 cannot be Rachel because Rachel's be $10 less than somebody. 50 is the highest amount. So the 50 definitely has to go with milk.
Yeah.
That for sure. Because there's no way Rachel could be because the one spent 50 is either Rachel or one forgot to buy milk, but Rachel's spending less money than someone else. Yeah, so I'm pretty sure that's gonna be the combination. That's okay. We'll just keep moving. I'm not gonna write proof for this. I'll just keep moving here. All right.
Oh,
So
wow.
let's do this one here. Okay. Go ahead and solve these equations right now as a quick warm up. Um,
Okay.
just again, you're solving for x.
Um, let's do it another time. Okay. Okay. 16. Equal is 12. Okay. It's
Oh, you made a mistake here. If you divide everything by 3, there should be 11, right? Because you have 33 plus 3x equals 90 for number one. Then you divide everything by 3, but the 33 must also be divided by 3. So you should get 19 as your answer. See, what I would have done personally.
What?
Okay, tell me what you're doing here.
I divided by three on both sides.
Right, but you didn't divide a 33 by 3,
Um,
right? Everything's got to be divided by 3. You know what you should have done was this. You were doing it a step a little bit premature. I would have subtracted the 33 first, right? And then
uh,
divide the 3.
I only get
Then you get 19,
18.
right?
Yeah.
That's what you need to do.
Okay, wait, let me listen to this. Okay. Uh, what? 3x equals 147. 49 equals 49. Hmm, okay. Okay.
Okay. Yeah, you got to divide by 2 afterwards here. Okay, let's keep moving. Yeah, so obviously if you so just congruent means equal, but obviously if two things are adding up to 180, so if angle 1, let's use a different color here.
Mhm.
If angle 1 plus angle 2 add up to 180, and angle 3 plus angle 2 also add up to 180, then angle 1 and 3 have to be the same.
Okay. But they're also adjacent. Right?
Well, not necessarily. They didn't draw it that way. I mean, we don't know
Okay.
for sure. Um, oh, I mean opposite. No, well, not necessarily. Um, yeah, 4 and 5 add up to 90, and 5 and 6 also add up to 90,
And 4 and 6.
and 4 and 6 have to be equal exactly. Yeah, because if you think about angle 4 plus angle 5 add up to 90, angle 6 plus angle 5, then angle 4 equals 90 minus angle 5. Angle 6 equals 90 minus angle 5. And since these are the same, then these are the same. So we expect that to happen logically. So it's all about logic, you know.
Yeah.
Angle 1 to have to 180. If they form a linear pair, meaning they form a line, they have to 180. If two angles are both right angles, they're both going to be the same because they're both 90 degrees. So let's look at a proof here. Hold on, we're trying to prove here. Hold on, I'm not sure what they want us to do. Um,
Maybe.
okay. I guess they want us to prove that angle. I'll just say what we're trying to prove here.
I'm trying to prove MN is equal to
I'm
QN.
guessing they wants to put angle NSP is congruent to angle R or QSR. So you can first off by saying angle MSN equals 50 degrees and
What's this?
angle PSQ and that's given. Okay. Also, we know angle PSR
Is equal to 90. That means QSR is
well,
equal
is
to
a right
40.
angle.
Yeah, okay.
That's also given.
And then NSP is also a right, or MSP is also a right angle.
Well, we could say angle PSR equals 90 degrees. And that's just definition of right angle. Um, or right angles are 90 degrees, whatever. And then you can say right angle PSR. And also same time you say angle. Actually, hold on, I'm just getting kind of confused here because I just don't know what they really want us to prove. It just seems confusing. Hold on. Let me see if we have a better proof because the more I think about it now, I think we're just kind of going down this rabbit hole. It's not really helping us. Yeah, I don't know what they want us to prove. I'm just so confused. Let's just not worry about it. I can show you something else. But vertical angles, angle one equals angle three. If they're directly opposite of each other, they're called vertical angles are always congruent or the same. So, like for example, for an angle two equals angle four. So for here, if angle one's 112, then that's 112. That's 58. That's 58.
Yeah, that's it.
If that's 67, yeah, angle two, 67, angle four is also 67. Then of course that's 113, 113. Um, yeah, that's 109, that's 109. If these are the same, then you send them equal to each other. That's pretty obvious.
Yeah,
And these are right next to each other, so they have to 180.
81, 81. So, 10, X is 10. Yeah.
Right. So, okay. Um, okay, so that kind of covers a good chunk of this. So yeah, so we could definitely kind of cover all this chapter two stuff. So I'll give you this for sure. Let me write this down. Chapter two review. And then also here, I'll definitely get some textbook problems as well. And I think it should be enough. And then we'll talk about chemistry next time.
Okay.
Um, and then on the 22nd, we could go back and do more geometry.
Okay.
And then we could alternate. Then we go back to chemistry on the 29th. And then after that, we could do a little more
Yeah.
geometry. And then that should be good. It should give you a good head start. And obviously, we'll be working throughout the school year. So
Okay.
cool. I do have to hop on another call. So I'll have to